Alright, let's now start with the exercises for the functions lesson. These exercises, well, start off pretty easy. We are required to define a function greeting with a Boolean parameter formal and a string parameter name, which prints either a formal or informal greeting addressed to name. Okay, so, well, obviously we have to define a function, and we are told that the function is supposed to be called greeting. There we go. Now we have two parameters, formal, which is a Boolean, and string name. Oops. And we are required to print either a formal or informal greeting addressed to name. So it means that if formal is true, then we are going to print, well, okay, good day name. Let's say this passes for a formal greeting. Otherwise, we say yo, and then the name that was passed. Very easy. Now this function returns void, because console.log returns void, and in general this function is not really returning anything, so it returns void. A function that returns void is also sometimes known as a procedure, but that's a bit of an old term. In case you run into it, you know, just be aware. Procedure is just a function that returns void. We can try it. So greeting formal Giuseppe, and I'm greeting informal John. Okay, let's run this. Let's make a little bit of room. Off we go. And good day Giuseppe and yo John. Okay, cool. Now we could also say that the Boolean doesn't really contain that much information. TypeScript does offer the possibility to actually define the type right away by saying that formal is either formal or informal. More about this. So the or means that, well, we can have only one of these two values. We will see this extensively in the lesson about custom types. The very neat thing about this is that the first parameter, you can see, it's not a Boolean anymore, but it's either of these two flags, formal or informal, and we even get IntelliSense, which is actually pretty awesome. So in this case, I'm going to say that Giuseppe gets the informal greeting, and John gets the formal greeting. Oh, brackets. There we go. And, well, you could say this is very much the same code as before, because a Boolean is just two values, but by using two flags with a clear semantic meaning, so that are easy to understand for the person who reads the code, instead of just true and false, it's actually quite a lot easier to maintain this code. Here we say prints. I would argue that you might also interpret this assignment as follows. And I understand I'm stretching a little bit the semantic of print, but I wouldn't mind, to be honest, to define a function that instead of printing simply returns a string, because the string is sort of the precursor to printing, but then we have the possibility to, of course, actually print with console.log, but we might also, I don't know, import fs, import star as fs from fs. Just be aware that in my package.json I did import types node, which, well, makes this directive typed, and so we can then decide what to do with this greeting. We can print it on the console with console.log, but we could also say fs.writefile sync, and then well, the file will be greeting.json. The data will be, you know, the result of calling greeting, and the format will be UTF-8, so we want to print this as a string. Now then just greetings.txt, And then by returning a string, we have a little bit more flexibility. So now I can see that I have the greeting.txt file, which is just printing. So I think it's fair, to simply say, what, when dealing with printing, don't assume that the printing will happen on the console and just return a string. This way you stay sort of a little bit more generic. But enough about this. Okay, now. The next one. This will require a trip down memory lane for some of us. So define a function to solve quadratic equations based on the parameters a, b, and c. How much would you have loved to have this in high school? Okay, so quadratic equation, and we get the parameters. A, it's a number, b, it's a number, c, it's a number, and we return, well, either two numbers, a number and another number, which are the two solutions, or we return undefined in case there is no proper solution. Okay, now I will open the browser. I will search for quadratic formula. There we go. So the quadratic formula is this: minus b plus minus square root of square b minus 4ac divided 2a. There might have been a time many years ago when I actually properly knew how to derive this. That time is long gone. Okay, so we have to calculate first the so-called discriminant. So let's do this. Const discriminant, which is b squared minus 4ac. And the discriminant has to be greater or equal than 0. So if discriminant is smaller than 0, then we have to return undefined. There are no solutions to this quadratic equation. Otherwise, we can return minus b plus the square root of the discriminant, and all of this divided by 2a, and that's one solution, and we return minus b minus the square root of the discriminant divided by 2a. Okay, so let's see. So here on Wikipedia we have an example, which would be okay, so quadratic equation. Now a is 0.5, b is minus 5 divided by 2, and this was then 1 divided by 2. Let's just put it like this. And finally c is just 2. Okay, and Wikipedia also claims the solutions being 1 and 4. Oh, 1 and 1/4. This is definitely not what we were expecting. So 1 divided by 2 minus 5 divided by 2 and 2. Okay, so b squared minus 4ac, and now we simply look at the formulas. Oh, let's see if it's as silly as, yes, it very probably is. 4 and 1. Yay! Very good. Okay. Yeah, you might think a silly mistake, but again, something like remembering all the operator precedence and making it intuitive is, yeah, it's something that I should have known, of course, but I'm happy that you see that sometimes a little bit defensive programming is good. So being too, how can I say, fluent in your typing of solutions is not always a good idea. So in case of doubt, brackets, and also in case of possible tiredness, possible confusion, possible stress, or not only inside your own brain, but also in the brain of the person who is going to read your code, well, that's a form of, you could say, defensive programming that, yeah, you might want to keep in mind. All right. Now, the next exercise will be define a function should play golf. Before we move on to the next exercise, let's play around a little bit with the possible different ways to define a function. Now, of course, this will be, let's say, the old-style canonical way to define a function. We have a function, that's the keyword, then the name of the function, parameters, return type, and body. Okay. But if you think about it, a function is no more and no less than just an expression in TypeScript. So we can assign a function, pass it to a variable, pass it around, etc. like any other normal value or parameter. This means that we could say that quadratic equation is equal to, and then the function expression. Now look what's happened. The thing on the right, and we don't even need this space here, is what we call an anonymous function, because it doesn't have a name. But I think actually a more accurate name would simply be a function expression, because it's an expression, it's, you know, something you can assign to a variable or put as an argument where a parameter of another function is expected, and so on. And as such, well, it's an expression, and the type of this expression is a function. Now, the function keyword is particularly interesting when we're going to see object orientation, because functions also allow us to define this parameter, which is a special parameter which behaves as a sort of context to the caller. But in this case of a simple function, we don't need it, and so there's an even simpler syntax where the function keyword is replaced by the arrow keyword. And this I really like. This I find very elegant, because this is saying, okay, we have these parameters, and these parameters go into whatever is returned by this body. Now in this case the body is quite long, so we actually have an extra constant, we have an if, etc. So in this case, well, the curly brackets actually make sense. But remember that if we're just returning a single expression directly, then we don't need the curly brackets and we don't need the return statement. So here's what we're going to do. We're going to take the discriminant, let's put it here, and then we're just going to return the result of a ternary operator. This is exactly the same as before, but when we directly return, in our case, with this way of rewriting the function, well, this expression, the discriminant, which I copied all over, well, it's mathematics, so this is not going to change. So from the maintainability perspective, this is sort of okay. But it is repeated, so unless the compiler is pretty smart, and there might be some rig computation. So this specific refactoring does have the side effect that it might be slower by some nanoseconds, but we can remove the curly brackets and we can remove the return statement, and there you go. In some cases, because this might actually be a sort of one-liner, well, you know, there's nothing wrong with it. Now, I'm going to do something that's a little bit down the deep end, but I want to show you how we can actually have yeah, okay, this is very silly, but you know, we're playing around here a little bit. We're going to see how we can actually reintroduce the constant in the form of a lambda. So when we define a constant, like assigning a constant, what do we actually do? So a constant, well, we have an expression, and the next thing we take is what to do with the expression, and then the result, and this returns the result of doing the thing with the expression. Okay, now let's actually put some types here, but I do need to borrow something we're going to see later, that is generics. So the expression can be whatever we want, And then what do we do with the expression? Well, that's going to be something that takes as input, the expression, and returns whatever the value b was. So we have the expression, and this returns b, and then obviously the full result is the b. And then what happens is that we simply call what to do with the expression with expression. Okay, now, so basically the parameter of what to do with the expression, this parameter here, is bound to expression, is bound to, yeah, that's what we do. So, I'm not really recommending to do this in practice, but look, we pass this as the expression, and then, well, we say that, no, not the comparison, not the comparison, not the comparison, okay, and then we say that this is the discrete, okay, that's a number, so now we have something that goes from number, and we're going to actually give a name to this number, which is discriminant. Now we can just use the discriminant, because that's sort of a variable. It's kind of funny, because when you have lambdas and parameters, you don't even need the actual variables anymore. And this is a way to have lambdas with the arrow syntax, even when you actually wanted to have constants. Yeah, so pretty, so insanely pretty. Okay, very good. Moving on to the next function. Okay, now, the next function that we are supposed to build is a function should play golf, which takes as input parameters the chance of rain, the temperature, and the wind velocity. One should only play golf if it does not rain too much, if it is not too cold, and if there is not too much wind. Try to make these thresholds dependent on external constants outside the function. Now, I'm absolutely certainly 100% sure that you remember this. I'm going to say it again just for myself, actually. At this point, you should pause the video, make the assignment yourself, and then take a look at how I do it. This way, I believe, you will learn the most. Okay, now, should play golf, and we take as input, well, chance of rain, which is a number. I'm being super lazy here, by the way. Then, because I'm trying to reuse things. Oh yeah, that's fantastic, because it's 3 parameters. Oh wow. Temperature and wind velocity. Okay, well, we have 3 parameters, so that's brilliant. Okay, so we're going to say, okay, now the chance of rain has to be bigger than, okay, one could say if the chance of rain is, let's say, smaller than 15%, let's say that the percentage is between 0 and 1, 0 being 0% and 1 being 100%, then the temperature is bigger than, I don't know, 16 degrees, that's not super cold, and the wind velocity is smaller than, I actually have no idea, I suppose 15 kilometers an hour, that might make sense, okay. Now, should play golf clearly returns a boolean. Well, I don't know if you saw it, but it's saying, okay, there you go, it returns a boolean, because the type inference works very well, especially when dealing with this kind of lambda, so functions without a body, just the arrow syntax. Usually TypeScript can guess pretty accurately what the return type is going to be. But we said we want to have these as parameters, as thresholds. One might say, okay, max chance of rain. So you could say, okay, max chance of rain is 0.15, and here we put max chance of rain. So we define these constants outside the should play golf function. The mean temperature, and we said that this is 16. And the wind velocity And let's see how smart extract constant in a flow. Oh, no. What have we done? No. Okay. Max wind velocity, this was 15 kilometers an hour. Okay. And this would be a way to finish the exercise. I'm also going to show something a little bit more functional, namely these constants. What if we want to be able to sort of change them, but well, in a sense they are constants, so the moment we get chance of rain temperature and wind velocity, the max chance of rain, mean temperature, and max wind velocity, well, they should sort of be the same. But you know what we could do? We could take them as parameters, but then in a staged way. So, look, now, max chance of rain is a number, mean temperature, it's of course also a number, and max wind velocity is also a number. Okay, what does this mean? It means that should play golf is a function that takes as input three parameters, the three thresholds, max chance of rain, mean temperature, max wind velocity. Then, after those parameters are given, what do we get back? We get back another function which takes as input the actual chance of rain, actual temperature, actual wind velocity. So, I could say, okay, should play golf thresholded, thresholds actually, because this is what actually happens. It's this function takes as input the thresholds and then gives us back should play golf. Okay, and this takes the thresholds. And I could say, okay, should play golf, so the actual function we call should play golf thresholds, and we set the thresholds. So I'm going to say max chance of rain is 0.15, mean temperature is 16, and max wind velocity is 15. I can also define another version of should play golf with different constants, should play golf 2, which, I don't know, is says, okay, no, we really want to be sure that there's almost no rain whatsoever, you know, for more delicate human beings. And there you go, and we could also have should play golf delicate, and then should play golf aggro for, you know, people who are afraid of nothing, so bring it on the rain, 3 degrees is not cold, and until the wind can push my car away, I am not afraid, you know. Alright. And you see this way, well, so max chance of rain is really a constant inside here, because it's a parameter, you can't change it, but we can sort of change these constants. And now, what's the type of these three functions? Well, should play golf, where it takes the chance of rain, temperature, and wind velocity, the second batch of parameters, and gives us the Boolean back. So we can actually call this and say, okay, should you play golf with a chance of rain of 0.2, a temperature of 18, and a wind velocity of 5, and then should play golf delicate, and should play golf aggro, and well, there you go, false, false, and true. In the first case, because 0.2 is above the threshold. In the second case, because 18 is under the threshold of temperature. And in the third case, well, those dudes will play golf in most cases anyway. Okay, these were the easy ones. We're now going to move into the domain of recursive functions. Recursive functions are incredibly important. And the reason why that is the case is that recursive functions leverage problems where you are able to identify a repeating structure. In a sense, they are like a while loop, but then a lot more explicit and on steroids. It is not a random thing that most powerful data structures, most powerful algorithms, even in real life, like anything that contains, you know, a tree, exploits this concept of self-similarity, which is as much a mathematical concept as it is a programming concept, and is best solved with the recursion. Something that people who know properly how to use with recursion will also notice is that recursive functions can solve very complex problems with very, very little code. So we're going to exercise a little bit with recursive functions. And let me remind you, a recursive function is a function that calls itself in order to, on different parameters than the current ones, in order to, again, exploit the self-similarity in the problem. Now we are required to define a recursive function to print all numbers within a given range. And here I will interpret print again as I want to just create a string with all the numbers. Okay, so print all, we have the lower bound, L, and the upper bound, so the first and the last. Okay, now, the thing is, if I want to print all the numbers in a given range, well, all the ranges look the same, with one exception, the empty range. The empty range is the range for which the lower, so the first number, is past, the biggest. So in this case, there's nothing to give, nothing to do. Okay. On the other hand, if the lower number is smaller or equal than the upper number, well, the range starts with the lower. But what do we put after? Well, what we put after is the range continuing from the next number and finishing again at u. Okay, now, because we're using print all here in a string, I'm guessing that TypeScript is having some trouble understanding what the type is, so I'm simply going to put string, and there we go. Okay, now we can say console.log print all from 1 to 10 to 5, and off we go. On the other hand, suppose now that we wanted to put a comma in between because it's neater. Now what's going to happen is, oh no, there is a trailing comma at the end. When you have a separator, and this is actually quite common, well, we just had one case, the last case, when we have only one element in the series, and in that case we simply say, okay, that's the last one, so we can stop. You might wonder, okay, but why do you still need the first one? Well, because the first call might start right away with an empty range. And now if we say 1 to 5, there we go, pretty as ever. Now this is so short, you might consider just having a single line, and you might feel that you're particularly hardcore in turning this into a one-liner. I'm not judging. Even though for readability purposes, I think, you know, the cases neatly aligned are slightly better, and perhaps even more aligned, but this might at some point border into the paranoia. Okay, now, define a recursive function to print all the characters in a string. Okay, separated by a comma, of course. Okay, so we do have the string, let's call it S, but then, then how do we do this? Well, okay, so let's actually call this A, B, C, D, E, F. Okay, so if the string dot length is equal to 0, then there's nothing to print. By the way, I do have an ingrown paranoia, so this is more of a side effect or a bug of my brain. Whenever I have a range, because now what I'm going to do is basically I'm going to just remove the first character and do the same thing we did with the previous implementation, but just by playing around with the string. But I've learned through experience that when something like the length in our case will decrease by one every time, I don't like to say equals to 0, even though for strings we're really safe because a string with a length smaller than 0 cannot really happen. But in my head this feels weirdly safer because I'm sort of saying, okay, if the range or the starting set is empty or for whatever weird reason that I can't think about right now, ends up being less than empty, which, you know, a range where the first element is bigger than the last one. The first the smallest element is bigger than the biggest. So these errors can happen. Then I try to put smaller equal than 0 because this covers more, you know, because otherwise I get infinite recursion as the range keeps decreasing. Okay, anyway. Otherwise, well, again, I have to check for the length being 1, because in this case there's only one character. And so what I will do is simply put s of 0 being the first character, and otherwise, well, clearly the length is bigger than 1, so we have s of 0, and then we follow by print all. Now I'm assuming there must be a way to get to split slice. I guess a slice will be the thing we want. So the start, that would be the beginning, yes. And I think s.slice of 1 just gives us the string with all the characters minus the first one. You know what I'm going to do? I'm going to validate this hypothesis. So I'm going to log a, b, c, d, e, f dot, oops, slice with 1, and I'm expecting b, c, d, e, f. Let's see. Oh, there we go. Okay, makes sense. Very cute. Now be careful, because this specific implementation with slice creates a copy of the string. For short strings you will not notice. For big strings this might end up being very, 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 very slow, because making this copy might take quite some time, especially because we're doing it for every character. For every character we're creating a copy with all the other characters minus that one. So what are we going to do? We are going to define what we call an intermediate function. So we have print all, okay, and here we define a function which I will call iterate, which takes as input the current character I, which is a number, and so instead of checking if the length is smaller or equal than 0, I'm going to say if I is greater or equal than the length. So if I has iterated past the length of the string, or and in that case, well, we're done. If I is equal to the length minus 1, then we are at the last character, so I just printed the last character. Otherwise, I print character I, and I iterate over I plus 1. Now, of course, I have to return iterate, starting from 0. Oh, and also here we can't really guess. Okay, very good. No, on this, I don't know. Yeah, that's right. Now this is the very same version, but it's very similar to a sort of while loop, but it's a recursive while loop. But in this case it's actually quite fast, because iterate will call itself only increasing the number, but we're not really creating any copies of the string. So there you go. Now let's define a recursive function to add all numbers within a given range. Oh, this is fun. Okay, so add all. We have the lower bound, and again the upper bound. And this is always a very similar principle. And you know, if you had to do this with a for loop or a while loop, which is obviously very easy to do, then you will need to introduce a temporary variable, which is probably going to be called I. And that variable, you know, it's kind of tricky because it has semantics. You have to think about it, and all of a sudden your problem is slightly bigger. It's also the problem of maintaining your intermediate variables, which I'm not saying in any way is impossible. A lot of people do it very well all the time, but with recursion it is possible to simply notice that, okay, if I want to add all numbers within a given range, well, I can simply start by checking if, well, is the range empty, like the smallest number, the first number in the range is already past the last number, so there's no range really. So in this case, well, that's 0, because there's no range to speak of, so the sum of an empty range is 0. Otherwise, there's at least L, so we say, okay, L plus, add all, and then, well, add we've already added, so we start again at L plus 1, and in this case you also have to state, okay, this returns a number, and there you go, add all And if we have 1, 2, 4, then this is going to be 1 plus 2, that's 3, plus 3, that's 6, plus 4, that is 10. So we do expect 10, and there we go, that's 10. Okay, and finally, we define a recursive function to multiply all numbers within a given range, and well, this is going to be very easy. So let's actually rename this to multiply all. Now, when the range is empty, because multiplication, well, if we multiply by 0 when the range ends, then we kind of break everything. So we have 1 as the last step, because 1 is also the neutral element of multiplication. And then obviously we multiply L, the first element of the range, with all the other elements of the range. Now I'm going to do 1 through 3, so it's going to be 1 times 2, that is 2, times 3, that is 6. There you go, that's 6. If we do 4, that will be 6 times 4, so that will be 24. Okay, very good. Now, you might notice that add all and mul all are basically the same function. The only thing that changes are the neutral element and what do we do with the two numbers of the range. So you know what I'm going to do? I am going to generalize this. So I'm going to call this combine all, and still, you know, this is the core of this function, combine all, but how do we combine? This will be, I'm going to put a question mark here, and here we have the second question mark. Okay, so this will be question mark number 0, and this will be question mark number 1. Okay, so we have two question marks, two parameters, if you will. And these parameters, well, we're going to pass them. So when empty, so this is the value we return when the range is empty. And then we have combine, which takes as input, well, two numbers and returns a number, and that's the second parameter. And now combine takes as input one parameter, that's a number, other parameter, that's another number, I'm not even bothering to give them names, and this returns a number. And why are we not happy? Oh, obviously, because combine all, well, now it expects also when empty and combine, but those don't really change, so we just pass them again. Look at the beauty of this. Add all now, because this is the first parameter and plus is the second parameter, so we just say, okay, this is combine all. When empty, well, we give 0, and well, we have the two values, I'm just calling them underscore and underscore, and we just add them together. What about mul all? Well, when we get to the end of the range, that's 1, and instead of adding the two values, we just multiply them, and there you go. Now this process of splitting a function into something staged, these are stages, like this is the first stage, every arrow is a stage. First we specify some aspects of the computation which might be at a higher level of abstraction if you want, and very often these are generic or lambdas. Then we have the actual parameters that will use these building blocks given at the first stage. Usually the first stage is more abstract and the second stage is more concrete, and then we have the general computation. And this pattern is super useful when you want to generalize code so that similar pieces of code are joined together into a common piece of code for usability. And if you look at how add all and mul all are now shorter, you can also imagine there could be other variants of this, and this is actually a well-known pattern in programming. And indeed, there are so many variations that are based on this generalization, not only two, that I will let you imagine yourself. Next function we have to define is a higher order function that combines three numbers in pairs. The arguments are the three numbers and the combination function that takes as input two numbers and returns just one. Okay, now let's unpack this definition first, because it's a bit daunting. A higher order function is any function that takes as input or returns as a result another function. So you will see multiple arrows in the type definition of a higher order function. And now we want to combine three numbers in pairs. So we have three numbers and we want to combine them 2 by 2. And indeed the arguments are the three numbers and the combination function. So because this combination function is a function, makes the exercise a higher order function. And this combination function takes as input two numbers and returns 1. So const combine 3. Now let's start with the combination function. The combination function takes as input two numbers. I will just call them _1 and _2, suggesting that I don't really specifically care about their identity, besides the fact that they are just two numbers, 1 and 2. Then we have the three numbers. And now, how do we combine them 2 by 2 or in pairs? Oh, no, this is ugly. Okay. We could say first, let's take AB, and this is the combination of A and B, and then we return the combination of AB and C. This would be an actually decent solution. Obviously, there is no repetition of evaluations if we just call combination within combination. So there you go. This is also a more, I think, visually appealing option. Shorter is cleaner. Notice that here the function that I've built, combine 3, is higher order because it takes as input a lambda, but also it returns a function because, you know, the combination operates at a more abstract level, and we can expect there will be a lot less combination functions than there will be numbers to be combined. And indeed, now we could say add 3 is combine 3, and now we take _1 and _2, and we simply add them together. And multiply 3, just multiplies the two parameters, and now we can console.log the result of, say, add 3, 1, 2, 3, but we could also say -1, -2, -3. So it makes sense that the actual adding operation has higher frequency than the frequency of swapping the underlying combination lambda. And similarly, you know, we could do the same for the multiplication. Let's do it here promptly, and off we go. There we go. I have no idea if the values are right. I'm guessing they are. Okay. Now we are tasked with defining a function greeting which takes as input a name and a lambda which adds a respectful prefix to the name, such as Dr., Mrs., etc., and prints the name with the prefix attached. Okay, greeting. Now we take as input a name and a lambda. Now, actually, the lambda will be the first parameter, as often has been the case. So prefix takes as input, well, the name, which is a string, I'm guessing, and returns a string. Then we take as input the actual name, and finally we return a string. And what are we going to return? We're going to return good day, prefix of name. Okay, now let's define some prefix functions. Doctor will take as input the name, being a string, and simply add doctor as a prefix. Oops. And Mr. will just add Mr. I'm just going to have this to avoid boring you with, you know, all the combinations possible. Because what do I want to show? I want to show that doctorify, or no, better yet, greet doctor will be greeting of doctor, and greet Mr. will be greeting of Mr. Okay, because we can assume there are a lot less prefixes than actual names to apply the prefixes to, so it really stands to reason that we want to encourage a different rate of variation of the prefix function, lower rate of variation. That's why we put it first, because we can put it as a sort of first stage, you know, with respect to the name, which has a much higher degree of variation. Because now I can print, okay, greet doctor, well, Giuseppe, I would actually, strictly speaking, be a doctor. Francesco is a doctor. Charlotte, whom I don't know, is a doctor. Maria is a doctor, and so on. And now you can see it does make sense. There's plenty of doctors in the world, but only one greet doctor function. There you go. And similarly, we could say that we greet Mr. Giuseppe, and there you go. Oh, I really like the elegance of applying lambdas and higher order functions, especially to define different, let's say, domains of specification of information through these staged parameters. Very elegant, really worth it to learn. We now conclude this unit with a very, 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 very complicated exercise. This exercise is super rich, insanely elegant, so let's go. Okay, now, this is the text of the exercise, not a joke. We are asked to implement a series of functions according to the given type definitions. So, okay, now, first one will be const char takes as input a string, another string, and returns a string. And what we expect this to do is that when we call char with two strings, it just adds them together. So this is actually quite easy. Okay, so char takes as input well, one string, just underscore, because here these are separate functions, so we can actually reuse the name underscore. No, not really, because otherwise we can't use them. So 1, 2 returns a string, and the string will simply be 1. No, in this case it's 2 plus 1. Okay, so this is not exactly addition. Let's test this. Actually, let's test this like this, and we get, okay, ABC star. That's what we wanted. Okay. Now we are asked to implement repeat. Now, what does repeat do? You can see here the example. Repeat takes as input a number, which is probably the number of repetitions, then a function, a lambda, that defines what to add to the current string for each iteration. And in this case, we take the number, we have the input string, and we simply take the input string plus the number. And finally, repeat takes, let's say, this base string. You could see this as sort of the context or the state of the computation, and takes the state and puts on top of it the repetition of this lambda. Okay, now, let's see. Okay, so repeat takes as input n being the number, then the iteration which will take a number, a string, and return a string. Finally, we take the state, or context is a better word. And actually, you know what, also for char, let's call this context. Let's be consistent, and this is the extra thing to be added to the context. Okay, and finally we have to return a string. Okay, now this will be a bit challenging, or maybe not. If, oh, pardon, let's say that n is smaller or equal than 0. So there are no repetitions. Okay, that's it's actually clear. Then we simply return the context because we're done. Otherwise, what do we do? Now we have the iteration, and the iteration we can use it to actually transform the context. So we're going to call repeat n minus 1. The iteration stays the same, and the context will be the result of passing the context through the iteration. Let's see if this works. Okay, so we have oh no, actually even easier, iteration of I and context. Oh, pardon, not I, but n. Let's see what happens when the signature works. Let's see if we're lucky. ABC 3, 2, 1. Okay, that's a little unfortunate because we are adding the string. Yeah, we're performing the iterations the other way around. No. Okay. Let's say we leave the context alone, but in here, yes, very good. Let's try. Let's say that we create a new string, but now we apply the iteration all around the repetition. So first we repeat, and then we put the iteration around it. And there you go, ABC 1, 2, 3. Okay, now let's play around with some figures. So an asterisk, okay, that's simply car of star. So let's say console.log asterisk around nothing, and this simply adds an asterisk. Okay, very good. But we can compose things. Asterisk, all. And let's see what happens. Oh, there you go. Okay, not incredibly exciting, but you know. Then we can define a new line. Oh, too many definitions. Okay. Now it becomes interesting. A line will be, well, will take as input the length of the line and repeat n times the asterisk. Okay, very good. Now we don't really care about the iteration step here, because for the line every asterisk we add is just the same. So now I can say line of 5 and then on top of nothing. And there you go. We could also, okay, it doesn't make a lot of sense yet, but I could say, okay, put, two lines of 5 next to each other, and this passing to the last argument actually concatenates, actually composes. Very good. Now it becomes interesting. A square will take as input a number, and it will repeat a line, but mind you, we can't just repeat the line, because we also need to add the new line at the end. Okay, how do we do this? Let's define a concatenation. Let's call it then. So we start with one figure, and a figure will take as input a context and return a string. Let's call this figure 1. Then we have figure 2, which takes as input a context and also returns a string, and then we compose these two things together. And how do we compose them together? Well, it's actually quite easy. Figure 2 of figure 1 of context. There you go. So basically, figure 1 will append a drawing to the context. And this becomes the context plus, whatever figure 1 has drawn. And figure 2 will take over from that and also append figure 2 next to it. So here, what I can do, because line of n has type context string, because it's a drawing function. So what we're doing is basically we're assembling drawing functions. We take the line of n and put a new line. Now, because I really don't want to... Oh, pardon. Yes, yes, I'm doing everything with carrying. Okay, because I don't want to be chasing ghosts here, and this is actually quite a complex domain, I want to make sure that... Oh, again, you know what? Let's merge it, because figure 1 and figure 2 aren't really separate semantically as abstraction levels. So let's keep them together. Now let me log the den of line 5 new line, because I want to make sure I'm doing them in the right order. Okay, yes, first you have the line, and you have the /n. So now I can simply say, okay, give me a square of 5, and put it on top of... put it on top of nothing. Now I don't really like this whole nothing thing, so I will simply say draw takes a figure and simply returns a string which is figure on top of nothing, because, well, this pattern we've seen it many times. So let's make it a little bit cuter to look at. Yes, draw square 5, it's exactly the same, but then that ugly empty context is not relevant. Okay, now let's define a triangle. What is a triangle? Triangle takes as input n, which, is the height of the triangle. Then we repeat n times, but every time the row we add has the same has the same length as the index of the iteration. So now if I say triangle of 5, there we go. And indeed, you might make your life a little bit easier by introducing this utility function, then which we have just implemented. Now, this exercise is insanely complicated, I agree, but also it's insanely powerful. It's insanely powerful because it allows you to experience what it means to have composition. Composition means that we build our program not just in terms of the program itself, but rather as building blocks that can be mixed and matched dynamically however you want. And look at this. And also look at how this bit of code reads: draw a square. Well, then you should read it in between. So a square, then a new line, then a triangle. Like, this is insane. And there are even ways to turn this around, but that's something for later, where you could say square 4, then new line, then triangle, and by hijacking the dot notation, you get into what some people call the fluent API, which reads a lot better because you have the combination operator after the operation itself. So you have, okay, draw a square, then draw a new line, then draw a triangle. But I mean, for now, for today, the basic computational concept is the core of our focus, and that would also be the basis for the other prettier implementation with .then. It's absolutely alright if this exercise feels daunting, if you have no clue how to manage this. I understand, no worries. But I wanted to inspire you a little bit to see something amazing, and also incredibly short, because look at how short this is, and for being a series of dynamically combinable, composable drawing primitives, I would say, yeah, this is quite exceptional. And this also gives you a sense of what you can expect from programming as you proceed towards becoming a true master. This is quite, I believe, a masterful example of an implementation. This is very literate, but you can find examples of this kind of code in practice, in production, at many of the major companies in the world of IT. So take this as an inspiration, take this as a sort of northern star that tells you what the code you write might look like after you grow up as a master, and also try to enjoy some elegance and beauty, because that makes life a lot better. Thank you very much for your attention, and see you in the next lesson.